Hey class, this is Mr. Roberts coming to you from my backyard. It's not raining. It's nice outside. I'm going to go over the Chapter 4 test. One of the reasons why I'm going over these tests like this is because this is great review for the final. So, not only as we wind down our final chapter, Chapter 5, as you look at these things, realize that a lot of these types of questions are likely to show up on our final. One of the things to be cautious of in the final is that a lot of common mistakes that you would make um, they're there as distractors for the test. So if it is multiple choice, so when you pick the A, B, or C, really be aware of what you're doing and a little bit critical of your answer. Just because you see an answer choice that's there doesn't mean it's necessarily the right one. So question one said for part A, find the output when 3 is input into this function. And then for part B, it says find the input that will produce an output of 12. So on this one, the deal is I'm placing the number 3 into this function, and the question is what comes out of it. One of the things that I want to do, first of all, is I recognize that this is something that can be simplified. And if I just quickly simplify that, I think it'll kind of offload some of the complexity perhaps of this problem. So I'm just going to go ahead and rewrite the x squared that occurred to start with. And the next thing that I'm going to go ahead and do is this is the same as plus 2 times x squared. So this is quite simple, right? It simplifies to 3 times whatever x squared is. And I can see that because this, right, I can simplify by, one of the ways I could do it is multiply by the number 1. So when I multiply by the number 1, which of course is allowed, it doesn't change the value of anything, you can see in the numerator I'm left with 2x squared, right, which is what I claim this is. In the denominator I have 2 times, or I'm sorry, I have x to the negative second times x to the positive second, which is x to the 0 power, which is 1. So this denominator just becomes the number 1. Well, 3 times x squared, in this case, x is the number is 3, so I have 3 times 3, and that 3 gets squared. I'm showing this with the parentheses. If x was negative 3, I'd really want to be careful to make sure I understand what is getting squared. In this case, what's getting squared is 3. 3 times 3 is 9, so this becomes 3 times 9, and 3 times 9 is 27. So for 1a, the answer is 27. For B, you can see we're asked to identify the input, right? Which input will produce an output of 12? Well, I want to know what x is when y is 12, so I'm just going to go ahead and set this equal to 12. So I'm going to say 12 equals 1/3 times sum x plus 8. So one way of looking at this is what value of x will produce 12, right? What value of x will make the 1/3 x plus 8 equal to 12? I'm going to solve that by subtracting 8 from both sides. If I do that, I get 4 equals 1/3 times x. And then to get rid of the fraction, I'm going to multiply both sides by 3. When I do that over on the left-hand side, rather, I get 12, and on the right-hand side, I get 1/3 times 3, which is 1/3 times 3 is just 1. So I get x has to be 12. So interestingly enough, when x equals 12, the output of this function would be 12. And I could verify that by plugging it in here, right? If I put the number 12 in here, 1/3 times 12 is 4, and 4 plus 8 is 12. So that is exactly what it is. X would be 12. Let's move on to question 2. I guess we'll just go ahead and do the first page here. So for 2, it says simplify completely. Answers may not contain negative exponents or common factors. So if I look at this first part, you can see that I've got x cubed squared. I'm sorry, a cubed squared, which means an a cubed times an a cubed. So just definitionally thinking about what does this mean, right? What does a to the 3rd power mean? That means I've got a factor of a times a factor of a times a factor of a. And because I'm squaring that, I end up with 2 identical sets of those. So I get a. So a to the 3rd raised to the 2nd power is a to the 6th power. And then I'm multiplying that times a b to the 2nd power times an a to the negative 5th power. Now, you can see this is all multiplication. There's no plus or minus inside of any of these. I can use the commutative property, or I can use the associative property and associate some of these things differently. But what I'm choosing to look at is the fact that I've got a to the 6th power times a to the negative 5th, which would just be a to the 1st power. So my answer, the most simplified version of this expression, would be a times b squared. So that's my answer for part a times b squared. For b, I can see that I do have a negative exponent, and I have the word hello. I don't know why that's there. Hello. I'm going to, let's see, I guess the one thing I'll do first is I'm going to clear this negative exponent. So I'm going to multiply this by x raised to the 5th power, x to the 5th power. And my purpose here is, now that I have x to the negative 5th times x to the positive 5th, that equals x to the 0, and anything to the 0 power is 1. So that's just a 1. If I was to rewrite that denominator now, it would just be a 12 and a y. In my numerator, I've got a 14, and I've got an x raised to the 8th power. One more thing that I can do, there is a common factor here with 12 and 14. 2 times 7 is 14, and 2 times 6 is 12. So if I look at those, there's that common factor of 1 that I need to eliminate. So the answer that I would write down is, I have 7 times x to the 8th power, 7 times 8 factors of x, over 6 times a single factor of y, 6 times y. So this is the answer for part B. Let's move down to C. For C, let's see, I don't have any powers raised to 2 powers. I guess I'll go ahead and simplify the numerator first. So if I'm looking at this numerator, 5 times 6 is 30. And then I've got an a, right, times an a to the 4th power, which would be a to the 5th power. And then times I've got b to the 3rd, b to the 3rd. And then that's all over 10 times b to the 3rd. Well, right off the bat, I can see that there's clearly a 1 in the form of b cubed over b cubed. So that's just equal to 1, so that's not going to be part of my answer. And 30 rather, divided by 10, 30 divided by 10 is 3. So it looks like our answer is going to be 3 times a raised to the 5th power. For D, again, the thing that I keep coming back to is just eliminating this negative exponent. So I'm going to go ahead and multiply by y squared in the denominator and y squared in the numerator. Again, it's totally fine for me to multiply by this because it's equivalent to the number 1 as long as y isn't 0, and multiplication by 1 doesn't change the value of this expression that I have. So in my numerator, I have 12 x squared y to the 2nd, and in my denominator I just have 4 times 1, right? Because y to the negative 2nd times y to the 2nd is y to the 0, which equals 1. So I'm just left with the number 4. 12 divided by 4 is 3, so it looks like my answer is going to be 3 times x squared times y to the 2nd power. All right, let's move on. Next question is A, B, C, D, E. So on this one, you can see I've got the number 4. I'm sorry, I have the number negative 4, which is being squared. So real carefully, I might go ahead and write out this is a negative 4 times another negative 4, right? Negative 4 times negative 4, which is positive 16. So order of operations important there. It is a negative 4 that's getting squared. My answer is positive 16. And on F, this is the opposite of 4 squared, right? 4 squared, 4 times 4 is 16. So this is 16, but it is the opposite of that. So kind of one of the ways that might help you see the difference here is this is the same as negative 1 times 4 squared. So you could look at it like this, which means it's negative 1 times 16. Negative 1 times 16 is negative 16. But it's also just the opposite of 4 squared, right? What's getting squared is 4, and it's the opposite of that. All right, so that's it for page 1 for the chapter 4 test.